So we're gonna move on to a couple other things. There's a couple new ideas that have also been floated out there with Wi-Fi 6. These are sort of things that are going on in parallel. One is something that might be a topic that we might get into a little bit later on in another discussion. That's open roaming. So there's actually an active working group out there today that's actually trying to tie together public Wi-Fi, private Wi-Fi, service provider LTE, and 5G networks, actually tying together authentication for both to allow you to be able to clients to intelligently roam between, that yogurt shop and the LTE network or the 5G network or the private, corporate network as you walk in and out, and actually have your device make good choices about what network you should be on. That stuff, it actually exists today. There's the initial deployments of it are already out there. This is a next generation of the Wi-Fi hotspot kind of technology that has been around for the last few years. This is about the third generation of what they're doing. But really being able to exchange authentications between cellular providers doing managing LTE and 5G networks, private LTE and 5G networks, public Wi-Fi environments, private Wi-Fi environments, and actually being able to federate a lot of those authentications so that my device, I don't need to move back and forth between these. It's actually going to have good information and telemetry coming into it that would actually allow it to make good choices for where it belongs for connectivity purposes. It's a lot of really interesting stuff, and there's more depth there that we can probably get into down the road. In addition to that, we've touched on it quite a bit, is the IoT stuff, whether it's, the smart shoelaces or shirts, or whether it's temperature sensor or Bluetooth beacons. So many of these things that are, or even, get into, the higher end of this stuff, PLCs, right? Things that are in industrial control networks, things that are managing, wellheads or manufacturing, lines, or, baggage claim or baggage claim systems, all of those devices that have historically, maybe they've been on the network, maybe not. As those things get added on, Wi-Fi could actually be a good way to do this with the new Wi-Fi 6 solutions. The predictability and the performance should be there. Those IoT devices, they don't talk much, but they may talk very frequently, just small amounts of information. And that today, that would eat up a lot of just service time on the channels that we have today. Wi-Fi 6 gives us more capability to deal with a higher density of devices without really sacrificing that. So these are just things as we're moving through this, that we'll have to keep thinking about and designing as we start doing upgrades and moving on with some new deployments. And then just to seed some new ideas of what's out there too, the next iteration of Wi-Fi will actually be Wi-Fi 6E. So in October of last year, the FCC approved the 6 gigahertz range for unlicensed use. This is a big deal. So there is 1,200 megahertz available in the 6 gigahertz range. That is twice the size of what we have in 5 gigahertz today. It's 14 times the size of the bandwidth that we have in 2.4 gig today. So it's a very different way to think about what we're doing, right? So you would have, potentially even starting from the fact, because you have twice as many channels to begin with, they're thinking that even in high density deployments, if we're doing a high density deployment in 5 gig today, maybe we have 40 gigahertz channels. For the most part, you're really worrying about access, not performance in those high density environments today. So maybe we're only dealing with 20 megahertz channels. But because the spectrum is so big and it is not used by much today. For the most part, it's used for satellites and cable retransmission today, and most of that would be outside. So inside buildings, 6 gigahertz is clear channels today. So 80 megahertz channels, you start thinking about 2 megahertz RU inside of an 80 megahertz channel. You got 40 potential clients that are all talking all at the same time, and then you add MIMO on top of that. So you get 4x, 8x communication on top of that. I mean, the amount of concurrent communication to clients that you could get is just amazing.
Hey, Jeff, sorry to interrupt. How does anybody know how that scales? Like the idea of uh, uh, so, as far as I'm a network engineer, man, it's just like this whole idea of how radio waves work and et cetera, et cetera. Like I'm curious, it's almost like a IPv4 to IPv6 comparison, like that type of thing, from a 2.4.5 to a 6. Uh, I'm concerned. The thing though is like how many bands are how many gigahertz bands is there? 7? Is there 8? Like how does that? Does
So if
anybody
you
know how
have
that works?
if you have 1200 megahertz, right? So each channel is 20 megahertz.
Yeah,
So what is that? Six, is that 60? Test my math. Is it
I
60
don't.
times 20? That's 1200, right?
Yeah,
So
I
you have
mean,
60 channels, but if you're at that point, if you're bonding them into 80 megahertz, right, you're taking four at a time. Um, you can see that you're still getting into maybe the same total number of usable channels that you had in 5 gigahertz, but you're dealing with it in 80 megahertz channel groupings at that point. So just from a scalability and performance perspective, it's if you think about the way that you can get RUs, whether it's a 2 megahertz, 4 megahertz, 8 megahertz, I mean, you could get a 20 megahertz RU. So the throughput that you get through that stuff is, could be amazing, just from a bandwidth perspective. But just the
I guess
communication perspective
isn't
is
there a
huge.
limited resource though? I mean, where's the limited resource exist? Like,
So the limited resource, and if you think about this now, is one of the discussions that they've had is this just going to be a code upgrade on existing hardware, right?
yeah,
Because from what the manufacturers are saying, the antennas are capable of doing it. Some of the manufacturers have their own ASICs that, they're saying that they can tweak the filters with software, and they should be able to do it with the existing ASICs. The challenge will be, if you think about it, is today they have to scan 600 megahertz of channels for contention and 83 megahertz for 2.4 gig, right? So there's a certain
Mm.
process that's in there to actually look for co-channel interference, for errors, for other communications that are going on, collisions, that kind of thing. Like if you think about, just that RF health check kind of functions that exist.
sure,
Okay, 6E is going to be twice the size. It's basically going to double the current total scanning time because there's so much more scanning that has to be done. And if we're
sure.
thinking about it in 20 megahertz channels, that's one thing, right? But when you start thinking about the fact that it's going to have to scan it's going to have to deal with OFDMA. It's going to have to deal with two gigahertz channels out of that. So there's 600 RU in 6E. There's only 300 in 5, and there's even less in there's way less in um, there's only 41 in um,
2.4.
2.4. So there just that is, I think, where some of the evolution will be is how much active processing is needed just to know how
Yeah,
healthy the RF is.
that makes sense. That makes
So I
sense.
don't think the transmission is going to be the real issue. It's going to be the monitoring side of it. And is the hardware, even if they can do software upgrades to be able to support the transmit and receive, do they have the horsepower to be able to scan more than twice or about twice the total bandwidth
So
in
it's
addition to
kind
what's
of
in
the
there
same
today?
as a quantum computing conundrum, where you just you hit a point where the device itself can't handle the computations to extenuate the technology to move forward, right? So it's not necessarily a physical thing. It's more of like a you can slice it down smaller, but your device has to compute faster or better, that type of thing.
Right. So I think where the rubber will meet the road with this is just to see, will the initial Wi-Fi 6 devices be software upgradable to support 6E in that 6 gigahertz range, or will they actually require a new AP at this point in time?
Man,
Historically, with these
yeah,
new standards, there's been new APs,
yeah,
and I think that from a safety perspective, just planning wise, I'm thinking that that's going to be the case, that they're going to have another set of APs with maybe
yeah.
a bigger set
I
of
agree.
scanning ASICs.
Mm-hmm.
That'd be a hell of a software upgrade, man.
Yeah, and as more, and the other side of this too, the compounding factor is as you add more processing into the APs, there's certain amount of efficiency that goes into that, but as you add more and more compute into the APs, you start pulling more and more power from the network too. So there's a trickle down effect that we have, that as engineers we're going to have to plan for as well.
Yeah.
But since this range is actually approved, it's available today for use, and we actually anticipate that at some point next year that there's actually going to start being clients and APs using 6 gigahertz. Um, for indoor use only. There will be some outdoor use that's going to be coming somewhat after that, and it's going to have specific rules because this is used for cable retransmission and satellites. Like you're going to have to actually measure how far you are off the horizon and things like that, so you're not interfering with
Wow.
satellite communication. So the interesting thing is though, with the amount of channels, some of the other things that you start thinking about is like, okay, if I need to get an AP over in that corner, but it's over my cable length, do I really need to run cable all the way out there, or can I start attaching Wi-Fi mesh stuff and actually use some of these channels as backhaul? Like,
That's going to all be about adoption, I think. I think if people start to get in their
Mhm.
head that wireless is as good as wired, then all bets are off. It could be
yeah,
anything, you know.
I think that you could come up with some really interesting creative mesh networks that wouldn't
Sure.
have the drawbacks of some of the mesh stuff today, just because of the increased channel density. Some of the other things that we're probably going to run into, it's just we're not going to get into any detail, but LTE, license assisted access, is basically carriers are deploying some backhaul and LTE functions in 5 gigahertz and 6 gigahertz. So we're going to see more and more of that in the 5 gigahertz range now, if we haven't seen it already. But we can also anticipate that that's going to also pop up in the 6 gigahertz that's out here as well, because anybody can use this. It's unlicensed spectrum. So if the carriers are putting in LTE networks or 5G networks, that I think that we should just plan that it's going to be one of the interference points that we have to monitor and take care of. Fortunately, there's more intelligence in a lot of our monitoring systems today, so hopefully it'll help us identify that fast.
Yeah,
For
right.
any of us that are working in Wi-Fi or with Wi-Fi environments in public areas. Um, so with that, I mean, that's some of the emerging pieces of technology. I kind of wanted to talk about a roadmap of where we think technology is right now and where it's going to end up. So this is, and I definitely want to get your input into a lot of this. I put these as a couple road markers for us to be able to talk about. But certainly this year, some of the big things that are coming up is that there's a lot of the 802.11n APs and controllers, that generation of equipment that's coming up on end of life the first half of next year. So as we're talking to clients, being able to take a look to see if they have any N only APs that are out there, or N generation controllers that, the N controllers, they definitely support some of the newer standards, but there is a generation of controllers there that's coming up, that's getting long in the tooth, and it's going to probably be removed from most networks in the next year. So it's something we should definitely be aware of. The Wi-Fi 6 clients are out there today. A lot of our phones and new PCs are going to have AX clients in them already. Some of the commercial stuff, even with cable providers, they're deploying, 6 APs out in the consumer environments. So it's definitely, the products are there. The manufacturers have verified 6 components that are out there for us to build those networks today. Um, One of the things that I think that as people are planning, if they are migrating from some of that older equipment to Wi-Fi 6, one of the biggest things that I would recommend is having those new environments really designed for 5 gigahertz from the start. I know that, we've been through this for a long time, and we've all complained about the fact that, we're dealing with networks that have APs that were installed, 2 generations of APs that were installed in the same physical locations they were in 2003, right? So, they're still planned for 2.4 gig. 2.4 gig radiuses haven't changed that dramatically. As we're starting to see what the advantages are in 6, like moving away from 2.4 as a primary access for a lot of our clients is really, I think, going to have a lot of benefits. We talked about 6E. One of the things that some of the RF engineers that I've listened to speaking, they actually anticipate that the radiuses for the cells in 6 are going to be similar to 5. Not that you won't have to redesign, but it should be fairly close. It's going to have performance characteristics closer to 5 gigahertz than 2.4 for sure. So as we start looking into next year, we might see some 6E clients. The replacement of that end stuff, we should start seeing a lot more of Wi-Fi 6 being deployed because the APs are out there now. Even the hospitality APs, which are usually on the trailing end of new development, those are even actually being announced at this point for hotels and residence halls and those kind of things. So
Jeff, do you mind if I interject something real quick?
absolutely.
Yeah, I just wanted to highlight something as far as the difference in waves and some of the information that I found. So yeah, like I said, is one of the key core features. It's OFDMA is going to be part of Wave 1. The new MIMO just for the downlink and the target wait time are all a part of Wave 1. And they're slotting the full uplink downlink for new MIMO, and the BSS coloring is going to be part of Wave 2. So there's no actual timing on any of this, but at the same time, it's just interesting to know that we're not going to be getting that BSS and the full MIMO capability right off the bat.
It might be interesting to see if whether that Wave 2 just coincides and whether there will really be a Wave 2 or whether it'll just be included in the 6E generation of equipment, right? Because maybe they're looking at that as, when the interesting thing is you get that new 6E equipment, it's going to have 3 radios in it, right? 2.4, 5 gig, and 6 gig. So again, thinking about how much power these things are going to pull. There's a whole generation of, we may have a whole lot fewer physical ports that are in the network, but we're going to have giant power supplies in the closets.
Yeah.
I think with just some of the first iteration Wave 1 stuff, that I had hung myself, I remember looking up and saying that some of these new 6 capable APs are somewhere towards, 50 watts for something that was going to be indoors and just something that can, calm and user office environment, which is what, 3 or 4 times, the 15 or whatever's allotted by the PoE. So it's drastically larger. And then you start getting into the switching requirements for these APs. As far as power constraints, that's going to change things.
What I have seen in the first not the initial offerings, but the follow-ups that I've seen right now is that most of the manufacturer stuff that I've seen will actually, with the current Wi-Fi 6 APs, will actually be supported with PoE plus. So we're still under 30 watts, but I think we're at 30 watts. And they actually, interestingly enough, they will power up with AT or with rather than PoE plus. With PoE, they just will turn off radios, so they'll be functional. They just won't have all the radios and capabilities. What will be interesting though is that when you add that additional radio in there, as it is, you're at the limit of PoE plus. I think when we start talking about Wi-Fi 6 and that additional radio, I think it's real easy to see that you start pushing over PoE territory, like 60 watts or under. And that's, again, that could be a major impact to people in their closets, right? If they move to Wi-Fi as the primary access at that point, maybe they don't need as many switches, but they're going to need big power supplies in those things because UPoE switches are going to, pull a lot. You're going to draw a lot more from the closets.
Yeah, that's interesting because at that point, cost, you have to look at cost, right? And so if you're looking to push over 60 watts, say we get to 60 watts, right? If you're looking 60 watts per port, as we have to support 15 watts per port on the PoE side now. And you have different technologies like stack power and stuff like that for a stacked switch or something like that, right? You currently can still maintain a one-use switch, but if you're talking 60 watts, that's a scale of 4 times what's on a particular port maybe today, and 2 times what are considered maximum. The power supplies would have to grow in size, I would imagine.
For sure.
if the power supplies grow in size, the switch most likely would have to grow in size, which would impact the footprint from a rack space type of thing. So potentially,
Potentially.
um, if
Or
that
maybe
becomes
even
the
be
case,
external.
yeah, I mean,
Oh
there's
God.
there's the thought process. Yeah,
I remember those.
I hope it doesn't go that way, but uh,
Yeah.
I mean, the possibility exists. So it'd be interesting as a like a parallel, right? Like in the video game world, right? You have this idea of a physical disc where you can put it into your PlayStation or whatnot, and then you have this digital footprint, right, where you can kind of download a game or something and not have the disc, that type of thing, right? Where it becomes a situation like that. Whereas from a business side of things, right? The idea of the potential for a bigger footprint on the physical side, physical media or physical boxes. A U costs money to an organization, right? When you go from 1U to 2U, right, there's a cost associated. Um, if it all boils down, right? So does the cost of going from a 1 to 2U box, or the space of the new power requirements, right? I'd be interested to see if this gets the right adoption rate, whether that pushes things toward an all wireless environment from a
Mm,
cost side of things. Is it
sure.
enough to tip the scale to start considering all wireless if power requirements get too great? You know, from a from a uh, from a what provides the power. Does that
No,
footprint become too big?
there's definitely a trickle down there. I mean, certainly on the switch side in the closets. I mean, if you have low density, it's going to be probably new switches. I mean, if you have higher density, I know a lot of people have, they may have switches that have power, a stacking power bus or something like that. So, there's more flexibility there to add additional power supplies into the stack and share some of that capability. But in the end, I mean, it also may drive some of these power supplies to be 220 rather than 110, and like there's a trickle down effect for cost, right? That's more panel space, that's new electrical,
Yep.
that's that all adds up as some of that stuff comes into play.
Co-location costs.
Sure.
If you were to, if all of your 1U switches became 2U switches,
Yeah.
as a standard, just to be able to support higher power requirements.
Is
I'm
there
not
all
sure. It's interesting.
It's all
It's
stuff that
interesting.
we're going to have to work through with our clients to make sure those power budget calculators are going to become real important. um, as we keep going through the rest of this, the big milestones are in 2021. We got the end generation stuff coming end of life. So that's projects that we're probably talking to clients with about right now. 2024, a lot of the AC Wave 1 APs are going to start coming end of life as well. So, you know, between 2021 and 2024, we should see a lot of Wi-Fi 6 deployment just because it doesn't make any sense for anybody to deploy anything else, right? Even a life cycle itself is going to drive adoption. What I'm hopeful about is that if people start looking at new facilities, that they might be looking at Wi-Fi first access and things like that, just to give them more flexibility with their workforce. How they're occupying buildings, how much cabling they need to pull, a lot of those things. And being on the early end of adoption for this, we see those standards last 6 years. The standards this before a new standard comes out, and then it's still sold for a couple years after that, and then you got 5 years of a tail of support, right? So being on the early end of Wi-Fi 6 deployment, I mean, you might see 10 to 12 years out of some of these APs, if you don't need to upgrade to, if you don't want to go to 6E or 6 Wave 2 or something like that. So I mean, there's the being on the early side of this with the life cycle updates. I mean, there's a long life cycle in some of this equipment, which is good. Um, I know Ed, you sent something over to the team the other day about what Wi-Fi 7 is and what's going to be included in it.
Yeah. Well, that was just like kind of a goof, but at the same time, it's like, this isn't for 6 to 8 years, but take a look, here's something else that's coming down the line. So, but,
And it was kind of
and then with that, the focus then goes right back to not so much on efficiency, but, back to power throughput. Just that perspective, it's like where we're at now and what, leaps and bounds we've done with HE. And it's like, yep, we're going to go right back to trying to improve throughput again.
And it was kind of interesting, like with that. I mean, reading that article, I'm like, okay, yeah, I get it. But then I went back and looked. I said, okay, when did the Wi-Fi 6, the 11AX, initial drafts actually start getting developed? And it was right about the same time AC was approved. So it makes sense. They're on sort of a 6-year life cycle, and whatever's in there now, I bet it changes between now and then. But at the same time, like they're not giving up. There's going to be a lot more and more development. And what's kind of interesting is that the architectures between 5G and Wi-Fi, LTE, 5G, the cellular side of this, and the Wi-Fi side, more and more of the architectures are starting to look more and more similar. What 5G and LTE do well were some of the new additions that we're starting to see in here. There's more channel reuse. There's, some of the things they were talking about in Wi-Fi 7 is actually scheduling transmission between APs on different, so you can actually overlap cells. That's all stuff that the cellular network does today. So it's kind of interesting to see these two things start, coming together. And like, at what point do they just turn into the same thing? Like, it could be over time that the differences between the two aren't dramatic enough to really drive adoption one way or the other.
Well, I mean, if you think about things too, to that point, I mean, I could see this. So this at first, right, when computing came in, right, it was more of like you would see it at colleges, right, schools, colleges. It was a developmental thing, right. As time went on, it became a business thing, right, where it was business productivity was the impetus. I think Windows NT 4.0 or something like that, where it was a business application. And then there was token ring, Ethernet, that type of stuff, and that was to facilitate business connections, right? We're at a point now where these things, these technologies are used in everything. So it's no longer it's no longer an academic thing. It's no longer a business thing. It's an do everything for everyone thing. Where I'm going with that is now that it's a do something for everyone type of paradigm within the world. I think you're going to see development of standards, the importance of standards. I think you're going to see workflow toward developing standards increase exponentially, to the point where it wouldn't surprise me if you started seeing standards being ratified every year, every 2 years, as things moved on.
Yeah, I mean, the tail end of that, though, that one of the things that drives this is the manufacturers, right? So, like, so even like TWT was part of a second standard or a separate standard that was specifically around that being able to set specific timeframes. They rolled it into the AX standard, but there was a working body working on that entirely separately. So I think a lot of that is already happening. But
Yeah.
at some point on the tail end of all of this is manufacturers actually making silicon and programming
Sure.
to actually be able to do it. So, I think that, to your point, like, the evolution of this technology isn't changing. If anything, it probably is advancing, even maybe more rapidly than it has in the past. But at the tail end of all this, they still have to make physical things, and they're probably going to need to keep those manufacturing lines running for a certain period of time. So it'll be interesting to see what that next standard looks like, and whether we see whether it maintains that 6-year cycle that we saw these last two times, or whether we see something that's even more aggressive than that. Because we can already see that the first generation of 6 doesn't include the 6 gigahertz radio, so there's probably a second generation of manufacturing that already we see coming up in 2 years, right? 2 or 3 years of new AP, another generation of new APs that are in there. But there's a lot of, Wi-Fi 6 is cool. Like, there's a lot of things here that I'm excited about. I know that we've all been kind of, as we dug into the details, I think all of us really were changed our perspective on how we're going to be designing a lot of this stuff moving forward. And I want to thank all of you for being a part of this discussion.